Welcome to Brain Vision.
We are told in the first statement the reaction of NH3 and oxygen forms NO and water. In order to balance the reaction, we will need to balance out our hydrogens first, given nitrogen is already balanced and oxygen appears in both products. Initially, we would attempt to balance by adding a 2 in front of NH3. That will give us 6 hydrogen, and a 3 in front of water, which will also give us 6 hydrogen, given the greatest factor between 2 and 3 is 6. We now have 2 nitrogen in the reactant. We will add a coefficient of 2 in front of NO in the product. At this point, we total up the oxygen on the right-hand side. We have 2 oxygen and 3, which is 5. It will be necessary to balance the reaction by adding 5/2 in front of our oxygen. The second statement read, the NO can be used to convert P4 to P4O6, forming N2 in the process. In this reaction, we notice that nitrogen is not balanced, and neither is oxygen. Adding a 2 in front of nitrogen, however, will not balance our oxygen. It will be necessary for us to balance out the oxygen first. So we add a 6 in front of NO, which now gives us 6 nitrogen, and therefore we will add a 3 in front of our nitrogen in the product. We now have 6 oxygen on both sides. Everything is balanced. The third statement read, the P4O6 can be treated with water to form H3PO3. Looking at this reaction, in order to balance, it will be necessary for us to balance our phosphorus first. There are 4 phosphorus on the left, so we will add a coefficient of 4 in front of the product. This now gives us 12 hydrogen. We will add a 6 in front of water, which will also give us 12 hydrogen. Adding up our oxygen, we have 6 here and 6 here. 4 times 3 is 12 in the product. The H3PO3 forms PH3 and H3PO4 when heated. To balance this reaction, we notice that phosphorus is in both products as well as hydrogen. So we will balance our oxygen first. The greatest common factor between 3 and 4 is 12. Therefore, we will add a 4 in front of our reactant to give us 12 oxygen, and a 3 in front of the second product to give us 12 oxygen. Now let's take a look at the hydrogen. We have 4 times 3, which is 12 here, 3 times 3, which is 9, plus 3 more, which is 12. Now let's go back and check our phosphorus. We have 4 here, we have 1 here, and 3 here, which is 12. All of our reactions are now balanced. So here are all 4 reactions again. The question given was, find the mass of PH3 that forms from the reaction of 1 gram of ammonia. So we are looking for the mass of PH3 given 1 gram of ammonia. In order to solve this question, we must see how each reaction is related. Notice from our first reaction that NO is formed and then used up in the second reaction. In our next reaction, we notice that P4O6 is formed and used up in the third reaction. We then notice that H3PO3 is formed and used up in our fourth reaction. So we will relate everything stoichiometrically through what we have noticed is made and formed. It will be necessary now to use mole ratios. We will begin with 1 gram of NH3. In order to relate everything stoichiometrically, we will need to first convert NH3 into moles. By using our periodic table, we notice that the mass of nitrogen is 14 and the mass of hydrogen is 1. Since there are 3 hydrogens, the approximate mass is 17. The exact mass is closer to 17.031. So adding our masses together will give us that there's 17.031 grams in 1 mole of NH3. Going back, we noticed that NH3 formed NO, and NO was used up. So we will use NO as our first ratio. Four moles of NH3 were able to form 4 moles of NO. Let's go back and take a look at the reactions again. 4 moles of NH3 were able to form 4 moles of NO. Then 4 moles of NO can then be related to the second reaction. In the second reaction, 6 moles of NO were able to form 1 mole of P4O6. So let's go back to our work. So continuing on with our stoichiometry, 6 moles of NO would form 1 mole of P4O6. Let's take a look at the reactions again. In the next reaction, we saw that 1 mole of P4O6 would form 4 moles of H3PO3. So that would be our next relationship. So continuing on, 1 mole of P4O6 would form 4 moles of H3PO3. Going back one more time, we'll notice in the last reaction, 4 moles of H3PO3 would form 1 mole of PH3, which is where our question was. So going back to our stoichiometry, we'll continue on the next line. We now know that for every 4 moles of H3PO3, we would form 1 mole of PH3. The last step would be to convert PH3 back into grams. We will use the periodic table, noting that phosphorus's mass is approximately 31 and hydrogen's is approximately 1. The exact mass that would tell us is that every 1 mole of PH3 has a mass of 33.994 grams. Now we'll do one more check before we calculate. Following through, we'll check our units. Our grams of NH3 would cancel. Our moles of NH3, our moles of NO, our moles of P4O6, our moles of H3PO3, our moles of PH3, and we should be left with grams of PH3. Now to do our final calculation. Work smart, not hard. Simplify your work before you plug into the calculator. So we notice that there's a 4 on the top and the bottom up here, so we're going to cancel those out. We also notice there's a 4 on the top over here and 1 down here on the bottom. So that simplifies our work. So now we'll work across. So looking at all of our top numbers, the only thing left is the mass of PH3. So on top we have 33.994. On the bottom, we now have 17.031 times 6 for a final answer of 0.333 grams of PH3.